Okay, let's look at a review of radicals and exponents for your final exam. Let's fill in the blanks here. When the same bases are multiplied, to simplify, you will add the exponents. When the same bases are divided, to simplify, you subtract the exponents. To make a negative exponent positive, you're going to switch from the numerator to the denominator, or denominator to numerator, depending on where the negative exponent is. When taking x squared to the 5th power, you will multiply the 2 and the 5. Okay, so let's work on some examples here. In this first example, number 2, I have a negative exponent on b, and I have a negative exponent on a squared. So what I'm going to do is I'm going to take whatever the base is that's attached to the negative exponent and move it. So I'm going to be moving b to the negative third down to the denominator, and then I'm going to be moving this whole a squared to the negative third up to the numerator. So when I rewrite this, I have the 2a from before in the numerator, and now I have a squared to the positive third power, and then that'll be over. I had 4b squared before, and now I have b to the positive 3 that I just moved. And then we can work on cleaning this up. So I'll need to take a squared to the 3rd power, which we just saw we multiply. So that will be 2a times a to the 6th over 4b squared b to the 3rd. Now since I have multiplication, I will be adding my exponents. So I'll have 2a to the 7th, and that'll be over 4b to the 5th. I do need to clean up my 2 and my 4 just like I would with fractions to make that a to the 7th over 2b to the 5th. Number 3 also has a negative exponent, but that exponent is attached to the entire parenthesis. So when I have that situation, what I like to do is just flip my entire contents of the parenthesis. So I'll make it 144x to the 14th, and that'll be over 1 to the positive 1/2 power. Now, I don't usually write that over 1 because it's understood that we don't need to write it if the denominator is 1. I'm then going to make my fractional exponent of 1/2. That exponent of 1/2 means a square root. So I will rewrite this as the square root of 144x to the 14th. And then I'll need to simplify that radical. So I'll break my number down. The 144 breaks into 12 times 12, and I could keep going, but once I see that I have 2 of the same number, they can come out of the radical, so I'll have 12 outside the radical. And then for x to the 14th, I want to know how many pairs of x's can come out, and then how many would be left in. So in x to the 14th, I'll have 7 pairs that will come out, and I'll have none left in. So that will be 12x to the 7, and there's nothing left in the radical, so that will be my final answer. Number 4, we're going to need to simplify these radicals, and they have an index of 3. So that index of 3 means that numbers and variables have to come out in groups of 3. So I'll take my 32 and I'll start to break it down. 32 would break down into 4 times 8. 4 would be 2 times 2, and 8 is 2 times 2 times 2. So I would have a group of 3 2's that would come out. 2 times 2 would be left in. But don't forget you already had a 2 out there. So I'll have 2 that was already out there times 2 that I brought out makes 4. And then the cube root of 2 times 2, which is 4 left in. And then subtract from that the cube root of 4, which I know won't break down because I just had that in my other problem. And then I'll look at 108, see how it breaks down. 108 would be 9 times 12. 9 would be 3 times 3. And 12 would be 3 times 4. I already know 4 won't break down, but I do have 3 3's, a group of 3 that can come out. And I already had a 5 out front, so that will be plus 5 times 3, or 15 cube roots of 4. And now I have some like terms because I have the same index with the same stuff in my radical, so I'll just combine these like I would variables. So I have positive 4, negative 1, and positive 15 is going to leave me with 18 cube roots of 4 for my final answer. Number 5 is a problem that's going to require me to rationalize the denominator. So what I'm going to need to do is work with the conjugate. Of the denominator. So I will need to multiply this by 1 minus square root of 2 in the denominator and 1 minus square root of 2 in the numerator. Now I need to remember that when I have two binomials multiplied by each other, I will be foiling. So I'm going to have to FOIL the numerator as well as the denominator. So it will be first times first. 5 times 1 would be 5. Outside times outside would be minus 5 square roots of 2. Inside times inside would be plus 2 square roots of 3. And then last times last, I have positive 2 times negative 1, which will be negative 2. And then square root of 3 times square root of 2 would be square roots of 6. Another way that you could do that foiling would be to use the box method, which I'll show you for the second one. If I have 1 minus square root of 2 times 1 plus square root of 2, just fill in the boxes. 1 times 1 is 1. 1 times negative square root of 2 is negative square root of 2. 1 times square root of 2 would be square root of 2. And then square root of 2 times negative square root of 2 would be negative 2. So my positive square root of 2 and negative square root of 2 cancel, and I have 1 minus 2 left, which is negative 1. We wouldn't want to leave our answer like that, so we'll divide each term in the numerator by negative 1, which will make this negative 5 plus 5 square roots of 2 minus 2 square roots of 3 plus 2 square roots of 6. And that will be as simple as it gets because I have no like terms in there. Our last two problems are solving equations with radicals. So let's look at number 6. On number 6, there's a radical on each side, and they're both cube roots. So I'm going to go ahead and cube both sides, which has the effect of getting rid of those radicals. So I'll be left with the equation 8a minus 4 equals 16 minus 2a. That is a linear equation, so I'll solve that by moving my variables to one side. So I have 10a equals, move my numbers to the other. So that's 20. Divide both sides by 10. I get a equals 2. And since I raised these both sides to an odd power, I do not have to check my answers. On our last problem, we'll need to start by isolating the radical. So I'll have to add 2 to both sides. So I get x plus 2 equals square root of 2x plus 19. And then I will square both sides. Now this time when I square both sides, the right hand side just gets rid of my radical, so I have 2x plus 19. But on the left hand side, I have to FOIL x plus 2 times x plus 2. So that will give me x squared plus 4x plus 4. Now this is a quadratic equation, so I'll want to solve it by either factoring or quadratic formula. So I'll go ahead and move all of my terms to the same side so that I get x squared plus 2x minus 15 equals 0. This will factor into x plus 5 times x minus 3. So I get x equals negative 5 or x equals 3. On this problem, since I raised both sides to an even power, I have to check my answers. And we're going to do that just by plugging in the values for x. So I'll go back to the original equation and put 3 equals the square root of 2 times 3 is 6 plus 19 minus 2. So that would be 3 equals the square root of 25 minus 2, or 3 equals 5 minus 2, which is correct. So x equals 3 works. Now let's check x equals negative 5. that would give me negative 5 equals the square root of 2 times negative 5 is negative 10 plus 19 minus 2. So that's negative 5 equals square root of 9 minus 2, or negative 5 equals 3 minus 2. And that is not right, so x equals negative 5 is extraneous, so that equation would only have one solution. Make sure you do go back and study your notes for this section, and you might want to rework the problems that are on this review. Good luck, and please study.